Google might have just changed RAG forever with the latest update to the Gemini API. They have introduced the Gemini File Search tool, and it's effectively managed RAG at a scale and price point that is absolutely disruptive. Alright, so I built this app using the latest Gemini API's File Search tool, and I want to take you through the process and explain what really happens. So here it requires an API key, which I've already selected. The option is for me to upload my own set of files, but I'm just going to use a Hyundai i10, which is a car manual, and I'm just going to say upload and chat. So the moment I do that, the first step is semantic chunking, which is breaking down the documents into meaningful paragraphs to understand the context. It is doing that for us. Second is document embedding, which is converting text into numerical vectors. Then the third piece is vector indexing, which is organizing text vectors into searchable maps for retrieval. Then you're doing layered retrieval, which is the next step after the index has been done. So you already saw like the number of steps that it took, which was completely automated for us. And I did not actually set up this on a RAG system. This is the Gemini API's new file store tool doing it for us. Now I can go ahead and ask a question. It's also suggesting a question that's pretty cool. So where can I find information about troubleshooting a common error? So what it is going to do is it is going to look into the document and provide the response. But the thing which I want to focus here is the sources, right? So this is the citation portion where it is behaving like a very typical RAG. But the beauty is I did not build the RAG system. All of this is embedded within the Gemini API. So a lot of the manual work that I would have had to do if I were using the end-to-end RAG process is now completely done by the API itself. And the best part is it is just an API call, right? So let's get back and discuss how is it different from large language models and what is the progression. And we'll also look into some of the code as we progress. You know, large language models like Gemini are incredible. They can write poetry, debug code, and explain kind of complex topics in seconds. They have a vast knowledge of the world, but they have one fundamental blind spot. They know absolutely nothing about your world, your documents, your company's private data, and your project notes. It's all invisible to them. For developers, getting an AI to understand this specific private information has been a massive challenge. The main solution generally used to solve for this is called Retrieval-Augmented Generation, or RAG. But building a RAG system yourself, well, that's been a complex, expensive, multi-stage engineering nightmare. Until now, the file search tool in Gemini API takes that entire engineering nightmare and turns it into a simple, elegant API call. So in this video, I'm going to go deeper into what this is, how it works, and why it's going to change how we build with AI forever. To really appreciate how big a deal file search is, you have to understand the old way, which is the hard way. The core idea of RAG is simple. It connects an LLM to an external knowledge, grounding its responses in actual facts. Think of it like giving the AI an open book test instead of making it answer from memory. The process has 3 steps: retrieve, augment, and generate. It sounds pretty easy, right? Not really. Building this pipeline from scratch is a serious project. It involves sourcing and chunking, which is breaking down your documents into perfectly sized chunks. Then creating embeddings, which is converting those chunks into numerical representations using a separate model. Then managing a vector database, which is setting up, managing, and paying for a specialized database to store and search these embeddings. And then building retrieval and ranking systems. Each of the steps that I just discussed is a massive engineering headache, or I should call this as infrastructure headache. It's a huge barrier that has kept this powerful technology out of hands of many developers like ourselves. So that is where this file search tool is really awesome. How is it different? Let's try and understand that, right? It's not, is it going to kill RAG or something of that sort? Not really. File search itself is a RAG system. The key difference is that it hides all of that crazy complexity. It is a fully managed RAG system that automates the entire pipeline. If you look at this diagram, the process is actually broken into 2 key phases. First, there is an offline indexing process. This is where the heavy lifting happens. File search uses a technique called semantic search. Unlike just matching keywords, it actually understands the meaning. When you upload a file, it's not just stored, it's automatically broken into chunks and converted into numerical representations, which we discussed earlier, called embeddings, which capture the semantic meaning of the text. These embeddings are then stored in that specialized database or file search store you see here. The whole flow from documents to embeddings to the database is that one-time indexing step. Then there is the real-time querying process. When a user asks a question, Gemini first decides if external knowledge would be helpful. If not, it just generates an answer. But if the answer is in your files, the yes path is taken. The model generates one or more optimized search queries. Those queries are also turned into embeddings and then used to search the database. The system finds the most relevant chunks of text, the context, and then feeds them back to the final Gemini model, which uses that context to generate a precise, grounded final answer. The entire sort of sophisticated loop that you're seeing here is what happens behind the scenes, completely managed for you by the Gemini API. Okay, so that's the theory aspect of it, but what makes it really game-changing is how simple is the code that you can use to implement. It's really 3 steps, right? So the first one is here, as you can see, you are creating the file store. The second step is where you are uploading and importing a file into that particular file store. It's really a single API call that kicks off the entire offline indexing process, right? So that's pretty cool. And when I say the indexing process, it is all about the chunking, the embedding, everything handled automatically for you, right? And you can see that reflected in the code. And then the third piece is really the query piece, right? Which is the final call is really triggering the real-time querying process. You just point the model to your store using the tools, and then it starts to generate the answer. It's just that simple, right? So from a mountain of complex engineering to just a few lines of code. And you can see there are multiple other options given for you to import the file. And then these are all the chunking and configuration, which is automatically handled for you by the tools. You don't have to worry about it. This is the diagram that we just went through. So that the 2 processes that I described. And then this is some additional information about how it kind of stores the metadata. All of this documentation is available that I'm happy to share as well. There are a few other interesting things which it also does. One of the things which it does out of the box again is citations. So once you upload it, is automatically able to provide citations just the way you look at the regular RAG. But again, this is automatically done for you, which is pretty cool. That is the code aspect of it if you want to implement it. So when you look at the code, you will feel that it's pretty simple to implement, but the implications are massive. Let's talk about the 3 biggest breakthroughs this enables. Number 1 is the speed of development. As you can understand that this is accessible through the API. It is going to be significantly faster to develop this. Second is the critical one, which is the cost barrier, right? This is very interesting because the data storage is completely free. So the creating of the embeddings at query time, that is also free. You only pay a tiny one-time fee for indexing your files and the standard Gemini rates for the context used in the final answer. And third, you don't sacrifice the power of simplicity. You still get support for dozens of file types out of the box. For years, the power to build AI that truly understands your private data was locked behind a huge wall of complexity and cost. With File Search, Google has just taken a sledgehammer to that wall. So the question is no longer how do we build this? The question is for you. Now that grounded AI is accessible, what will you be building? Please let me know in the comment section, your thoughts about this. I'm very interested to hear what you plan to build. And as always, if you found value in this video, please hit that like button and please subscribe to the channel so that you don't miss out the next videos. Thank you very much for your time. I will see you in the next one.